surface would reach a height of s equals 832t minus 2.6t squared after t seconds. And for part A, it says to find ds dt and d squared s dt squared, and what do each of these represent? So first of all, if we find ds dt, that's just the derivative of s. So ds dt will equal the derivative of 832t is 832 minus the derivative of 2.6t squared will be 5.2t. And then it asks us to find d squared s dt squared, which is just the derivative again. The derivative of 832, since it's a constant, will be 0, and the derivative of minus 5.2t will be minus 5.2. And then it says, what do each of these represent? The first derivative would represent the velocity of the bullet. The second derivative would represent the acceleration of the bullet. Okay, it says, how long does it take the bullet to reach its maximum height, and what is the maximum height? How long is the time? So we're going to be solving for t. And then what is the maximum height? They're asking for a height, and we know that that's the position, which will be s. So that's what we're solving for. When it says how long does it take the bullet to reach its maximum height, when it goes up into the air, when it gets to its top spot, the velocity or the derivative up there would be 0. So we're going to take ds dt and set it equal to 0. So we're going to have 832 minus 5.2t equals 0. And then from here, I will add 5.2 to both sides. So I'll get 832 equals 5.2t. And then if I divide both sides by 5.2, I will get t equals 160, and that would be seconds. So it took 160 seconds for the bullet to reach its maximum height. And it says, what is the maximum height? So now we're going to go into the position formula, and we'll plug in 160. So we're going to have s equals 832 times 160 minus 2.6 times 160 squared. And then if you figure that out, and we do get to use our calculator to do this, we'll get 66,560, and it didn't give units, but it should have. This was in feet, and it will on a test tell you what your units are. So that is how high the object reached, or the bullet. And then see with what velocity is it fired? Well, when you're firing it, that would be at time equals 0, and we want to know the velocity. So we're going to find the velocity, or the first derivative, when t equals 0. So we're going to have 832 minus 5.2 times 0, which means our beginning velocity is going to be 832, and if I'm dealing in velocity, it will be feet per second. Problem 2. Find all values of x for which the function is differentiable. Hint, zoom in once, and you definitely need to use this hint if you want to get the right answer. Differentiable, remember, just means you can take the derivative. So where are you allowed to take the derivative? So if you use your calculator, just go to y1, enter it exactly how you see right here, and if you do zoom in once, if you just hit zoom and then pick zoom in and press enter, you're going to get a picture that looks like this. Oh goodness, it should hit right at 0, sorry. So you're going to get a picture that looks like that. Please notice that we have a cusp happening at x equals 0. So this is not differentiable because of the cusp at x equals 0. So when it says where is it differentiable, it's going to be differentiable from negative infinity until I get to 0, and then from 0 to infinity. Number 3, find the slope of the curve at x equals pi over 3. Okay, slope of the curve is just the derivative, and we are in a calculator section, so we get to use our calculator to do this. So you are going to type this function into y1 in your calculator. When you're done, you're just going to quit, and then you will pick Math 8. When you do that, you should have something that looks like this. We have a little box, be parentheses, and then there's going to say x equals another little box. All right, so remember, we're going to put x in that first spot. This one, we will put y1 in that place, and remember, to get there, I believe we do second trace. You will be able to find that y1, and then we want it at x equals pi over 3, so then you can just type in pi over 3, and when you do that, you will get negative 1.451, so that is the derivative at that spot. Okay, number 4, at each point indicated on the graph, determine whether the value of the derivative is positive, negative, 0, or the function has no derivative. Explain your choice for each part. So if I'm looking at A, I'm seeing a sharp turn at A, so I know there's going to be no derivative, and I can just say because of a sharp turn. Okay, for B, I notice B, if I drew a tangent line there, the tangent line, the slope is negative, so we are going to have the derivative will be negative, and it's because the tangent line has a negative slope. And then if I look at C, if I drew the tangent line, has a horizontal tangent line, which means the derivative or the slope will be 0, and that will be because there is a horizontal tangent line. And then D, if I draw it, even though it is on the x-axis, if we draw the slope of that tangent, if we draw that tangent line, notice the slope of that tangent line is positive, so our derivative will be positive, and that will be because the tangent line has a positive slope. Okay, number 5, assume f of x is a continuous function, and the chart below represents a selection of its function values. Estimate the derivative of the function at x equals -1. Notice this time x equals -1 is actually on our chart, but derivative, remember, is a slope, and to calculate a slope we need 2 points. So actually there are 3 different ways that you could do this, and I'll do all 3. The first way, I could pick these 2 points because that would actually contain -3. So I could pick the point -3,6 and -1,8, and if I found the slope, remember it's y divided by x, so I'm going to have 8 minus 6 over -1 minus -3. That would give me 2 over 2, which reduces to 1. Okay. The second way, I could use the points going the other way. So I could use the point -1,8 and 1,9, and if I found the slope that way, we'd get 9 minus 8, remember doing the y's on the top again, divided by 1 minus -1, and that will give me 1/2. All right, and then the third way that I could calculate this is just to pick numbers on each side of -1. So I could actually use the point -3,6 and 1,9, and since we're just estimating, any of these ways would totally be fine, as long as whatever we find is somehow surrounding the x equals -1. Again, using the y's on the top, I'll have 9 minus 6 over 1 minus -3. That will give me 3 over 4. So any of those ways would be 100% correct.